Assalamualaikum warahmatullahi wabarakatuh. Now we go to the last example in this chapter, which is example 4. This example 4 is about frictional losses through pipe and fitting. So we look at the question first. Find the pressure at the inlet to the hydraulic motor, which is at station 2. Given pressure at station 1 in the hydraulic tank is atmospheric. So this is the level 1 at the surface of the water is 0.1, is 0 for the pressure. The head loss HL total due to the friction between station 1 and 2 is 9 meter. It's given here HL total is 9 meter. Okay, HL total 9 meter. Okay, now the first thing we need to write down the general equation, which is we call it as energy equation. Okay, we write down first the energy equation. P1 over gamma plus V1 squared over 2G plus Z1 plus head pump equal to pressure at 2 gamma plus V2 squared over 2G plus Z2 plus with H turbine, and last one is plus with HL total. Okay, first we need to analyze the system, the piping system. We go for point number 1 first in here. The point number 1 at the surface water. So for the pressure at the surface water, P1 is 0, same with the velocity at surface water is also become 0. And also what else? We also have the pump power here. So from the pump power, we can calculate the HP. And volume flow rate here, we can calculate from here, we can calculate the V, velocity. Inside the meter, we can get the area, specific gravity, you can get the density. And the elevation station is between Z1 and Z2 lah. And now we go to the equation. So P1 is 0, V1 is 0. Now in this equation, we have the head pump. We can get from here, pump power. But we don't have the turbine. So we can cancel out the turbine here. So at the end of the equation, it becomes P2 gamma equal to HP plus Z1 minus Z2 minus with V2 squared over 2G, and also last one is HL total. So now we go one by one. We calculate first for the HP, which is come from the pump power. HP equal to pump power divided into rho G and Q. WP is equal to 3730 divided into rho. Rho is come from specific gravity. Specific gravity is equal to density of substance divided into substitute density of water, which is 1000. So we want to calculate the density of substance divided into 1000. And the value for Sg is 0.9. That's it. Density for the substance, which is oil, 1000. So the end, our density of oil is become 900 kilogram per meter cube. So now we substitute the density of oil into HP. 900 times with 9.81 times with the Q is already given, 0.001896 meter cube per second. The end, the HP, we will get the answer for 222.8 meter for the HP. Okay, now we go to calculate for the Z1 minus Z2, elevation difference between the 1 and 2. For the elevation difference, Z1, we want to find for the Z1 minus Z2. So if we assume level 1 as a 0 here, atas upward until the level 2. This is level 2, this is level 1. It will become positive. So now Z1 is 0, and the difference between these two and going upward thus is a positive 6. So we just write down 6 lah. And the end, Z1 minus Z2 is negative 6. So we have the value for Z1 minus Z2 is negative 6 here. So what else? Oh, we don't have the velocity 2. The velocity 2 is come from the volume flow rate. Volume flow rate is given. So now we can have our V2 by using this formula. Q is continuity equation. Q equal to A2 V2. So we have the area inside diameter here, so that we can get the area 2. And want to find the V2. Q equal to A2. Since the given is diameter, we just convert into radius. It becomes 0.01 radius. Q divide to pi r squared. R is 0.01, and the end you can get the V2 by substituting the value is 6.035 meter per second. Okay, now we have the V2. Also we have the HP. Z1 minus Z2, we substitute into the final equation here. HP 2.8 plus with negative 6 minus 6.035 squared over 2g minus width HL total 9. When you settle all the calculation here, the P you can get the 1818.5 kilo Pascal. Okay, I think that's all. If you have any question, you can direct ask your lecturer for the further explanation. I think that's all for now. Thank you guys.